Oh, that'll work. All right, this thing's on. Anybody remember end of class Tuesday, I said, come to class today prepared with something. Anybody remember what I said? Anybody? Raise your hand, be proud. I said, come to class prepared to ask questions. And so I guess you're always prepared to ask questions if you don't know what I'm talking about. So, you guys are a group? You guys are a group? You guys are a group and you two are a group? All right, one of these two groups join together. You don't have to move right now. But, and yeah, that'll work. Just for today in class, you guys join together so you can have a bigger discussion. Two people can't really discuss anything, they can just argue. More than two people could discuss something. All right, so each group is a consulting company. You're a consulting company that does robotic, or I shouldn't say robotic necessarily, because a robot doesn't have to be your choice. But you're a consulting company that does factory automation. You do automating of manufacturing factories. And the way you do that is by you understand the customer's needs, and then you figure out the best system to solve the customer's needs. Cool. Which group are you in? That one. Okay, perfect. All right. Did you see online that we were doing group stuff and you decided to run over? Look at that.
No, it just actually took me 20 minutes to walk to campus.
It is, oh my God, cold out there. Worcester Public Schools are canceled today because it's too cold.
Wow.
Yesterday because 4 inches was too much snow. Today because it's too cold. All right, automation case study. You're a company. You're called into the office of the company that wants to have automation, and you've got to ask them a series of questions in order to help them solve their problem. And so here's what you know so far. So we're gonna break this up into a couple different steps here. But what you know so far is that you've been invited to visit a company called Icy Hot Heat Treating. And Icy Hot Heat Treating has a process that they want to automate. And unfortunately, the contact was made without a lot of details getting passed on to you. So what I'd like you to do is take the next 10 minutes, maybe too long. Take the next 7 minutes to, in your group, make a list of the questions that you want the answers to when you arrive at the customer site. So all you know is the name of the company is Icy Hot Heat Treating. They have a process in their facility that they would like to automate. It's currently being done. So they're currently doing the process. They're doing it manually. People are doing the thing. And they want to automate that. So think of, with your group, what questions you want to ask the management of Icy Hot when you arrive. Okay, so we'll do about 7 minutes. Let's see if I do Y-O-U-T-U-B-E tab 7 min timer. Well, that didn't work. All right, so again, Icy Hot Heat Treating. You're going to go there to meet with the management to find out what they want to do, and you got to have a list of questions prepared. Because if you just show up there, then you won't be able to get the information you need. Because you're going to have a short meeting there. You're going to then propose a system and try to sell that to them.
Okay, yeah.
So I said that you're consultants, right? But you're beyond consultants. You're actually a system integrator. So in this role, you're consulting with them because you're trying to help them decide how to automate what to do. But if they choose to go with your proposal, then your company is going to get the job to design, put in the system. So it's a little bit beyond consulting. And I just wondered, anybody think they might have a job after they graduate? Sometime go work at a company? There's a good chance that you'll have to do something like this on your first week at work. So it's a real thing. You guys all ready? You got your list of questions ready? Are you guys all ready? We do not have to wait for the countdown timer to get to the bottom. All right, so you guys have got some questions now? Let's see. I guess, what do we got? 1, 2, 3 groups, right? So we'll go around and you guys can take turns answering questions. So what do you guys got for a question? What is that the first question you want to ask? Quickly take 30 seconds and order the questions in the order that you want to ask them. on your piece of paper there. Just put 1, 2, 3 next to the things. You guys ready? All right, who knows their first question? You guys get your first question? What is it? What's the product? Okay. So that's a fair first question. So the product in question, so what product? So the product in question is a bearing race. Have you guys seen like ball bearings, right? And so the metal parts that go around the outside and around the inside there, those are called the bearing races. And so the product in question is a bearing race. And it's actually a part family. RACE? Yeah, it must be. Bearing race. And it's a part, which means, so part family means all of the parts are very similar to each other, but they're not all the same. And so what I can tell you about the product is they all have an outer diameter and an inner diameter. And they all have a thickness. Right, so they're roughly this shape. They also have an orientation. They have a top and a bottom. So there's a orientation on these particular parts in this part family. So the top doesn't look like the bottom, and you have to understand that. So that is the that's the part. That's the product. Anybody have a different first question? That you guys went first, right? That was your first question. Anybody have a different first question? It's okay. That wasn't necessarily my first question.
What's the process you want?
So I might have gone with process first, but you're right. It's who cares about the process if you don't know what the part is? So yeah. So what's the process? And so the process that they want to automate is part of the heat treating process. And so the way that these bearings, so you guys know what heat treating is? Right, you change the temperature to something, maybe you soak there at a certain temperature, and then you cool it at a certain rate. And so we'll do this on these bearing races, especially to make them harder, so that they're more wear resistant. So it's vital to the performance of the bearings to do this heat treating process. And so what they're doing currently is they get a wooden crate. You guys have all seen a wooden crate? So it's a wooden crate that's built into a pallet, so you can lift it up and move it with a forklift, full of these bearing races. It comes in, it gets set on the floor near the heat treating furnace. Now, in order for the bearing races to go into the heat treating furnace, they have to be stacked in these metal wire baskets. And so the wire baskets, look, let's see if I can draw the wire baskets. Right, so side view of the wire basket here, sort of that shape. Never mind. I'll make a new picture here. Because when you stack them in it, the wire basket is in this upright orientation here. And so that's sort of a side view cross section of it. And then when you look the front view of it, it's got right, so we're looking down into it, and there's like a grid of wires. And so it's sort of shaped like this. And so if you guys understand what I'm talking about, a wire basket, it's like a basket made out of wire. And when they stack them, the basket's up like this, and they put them in rows across the bottom and then stack rows on top of each other. And so the stack of bearings inside this wire basket, or bearing races, sorry, it looks like this. And so they're basically trying to fit as many bearings in this basket as possible, but have as little contact between the bearings as possible. So they want to have as much space available between them so they're getting hit with radiant heat from the furnace instead of conduction from the other bearings. So you don't want them to be touching each other as you want them to touch each other as little as possible. So we just stack them in this basket. And so currently they get two guys. And when one of these pallets comes in, the two guys spend half a day stacking them. And they're, it's ergonomically poor because they're moving them around, all that stuff. And they would rather have those two guys do something more useful than fill up these baskets. Now, once the baskets get filled up, they're put on a chain conveyor. So they're hung from a chain conveyor. And then that chain conveyor brings the baskets into the furnace, brings them back out of the furnace. And then I never talked to them about the unpacking. I believe they just dump them back into the crate. I think it's that unsophisticated, although I never actually asked them about the unpacking process. Okay, so the process that they want to automate is putting the bearing races in the basket and getting the baskets loaded on the chain conveyor. So the chain conveyor is already as automatic as it's going to be. They press a button, it goes in, it comes back out a few hours later. All right, so we got product and process. And so product, again, was bearings. Process is load. Load bearing races into baskets for the heat treating furnace. What's the next question? Did you guys do a question yet?
No. So you kind of answered what our third question would have been, which we said what were they sort of looking for with automation, like what was the goal? We went over that.
So
our fourth would be their budget and like their time property.
So you mean the budget for the project, right? And by size of operation, you mean how big is the company or how big is this process?
Like how many bearings do they use per day?
Okay, so volume.
Yeah.
So yeah, it's just terminology. So volume. So the number of bearings per day is going to vary depending on the size of the bearings. So they can go all the way down from like a 1-inch OD bearing up to, I think their maximum size there was like 3-inch OD, and there's some different sizes. And so you'll fit more in a basket if they're smaller bearings. So the volume goes up there. The number is going to change. It's really the number of baskets per day that they were counting. And some of this I'm doing from memory because this is actually a project that I worked on. Some of it I'm just making up off the top of my head to answer your questions. And I'm not going to tell you what because it doesn't matter. but the number of baskets per day is about 7. So they want to do about 7 baskets, or they're currently doing about 7 baskets per day. They can get the bearing races faster. They didn't indicate whether or not they wanted to speed that up, but I think they want to be able to have that control. So about 7 of these baskets a day. Currently takes about 2 hours to fill up a basket manually, right? The person place thing. You said budget. So they don't always come out and tell you what the budget is. But they did mention in passing that they already had a quote for $50,000 from somebody else. And they also gave you some details. That person that gave them the $50,000 arm, they were going to pick the bearings up, put them in the thing, and they didn't have any more details to share with you about that. But you know that they've got a price of $50,000 and that they're still asking you for a price. So they didn't jump out of their skin and love that price. The company itself, no, when you asked the size of the operation, I thought you meant the size of the company. The company itself has about 100 employees spread out in several different locations. They do more than just heat treating. This is sort of the heat treating division of the company. The company actually manufactures the bearings. So the parent company manufactures the bearings. This is the heat treating facility for the bearing manufacturer. You guys have another question? What's the next thing you guys want to know?
How much are they selling for?
They go, so bearings will range in price anywhere from about $13 to about $50 per unit. That,
How long it takes
so it takes them about 2 hours, 2 man hours per basket. So if there's 4 people, well, 4 people probably can't crowd around the basket. So they usually do it with 2 people. They get 2 baskets at a time. Yeah. Half the size of this table. A little bit smaller than half the size of this table. Yeah.
What's the weight of a basketball bearing?
Heavy. 100 pounds, 200 pounds. Basket full of small bearings is going to be more heavy.
How big is the
So you take one of these baskets, you hang it on the chain, and then the furnace itself is probably from here to the wall. If I stand like this. So you could measure it. And if you measure it, you might get what is that, like 12 by 15 feet or something like that. The sort of the area that the furnace occupies. And the chain thing is right in front of it. Yeah. Another question. What else you guys got? You could propose it, but they're already sort of using the conveyor. They're just they're batching the conveyor thing. So you're thinking hang one bearing at a time to go through? Yeah, which would actually be a novel solution. You'd need to totally get a new furnace, new plant layout, all kinds of stuff like that. So I don't think they'd be willing to do that. But I don't know for a fact. I think that would cost a lot more than just automating the basket thing, though. Yeah, that's a problem. That was a good question. So the space that's available, They've got a loading dock door here, so overhead door here. And that's where the pallets arrive. The furnace pretty much takes up this space here. Yep. You guys ever been to like a manufacturing factory facility like this? So you know they have those yellow aisles that go all the way through the factories that you're supposed to not spend too much. Well, you have to move out of the way when you hear a fork truck coming, because that's the aisle where the fork truck goes. So the fork truck aisle kind of goes right in front of the furnace here. The parts go in, the chain conveyor goes like this, brings the parts in like that. I think it comes out over here. So I probably drew that a little bit too close to the wall. But yeah, so you hang them up over here, sort of just out of the forklift aisle. Forklift aisle does this, turns a corner here, goes over to that, and then it comes out from here. And so there's a door that goes to another room over here that the forklifts go through. There's a little space. Oh, and here's the wall, outside wall, or internal wall. And so here's a wall. Here's a wall. And so currently, they drop the pallets here, and they use this space to fill up the baskets. And there's probably pallets of bearings haphazardly around here. And so we're working between the furnace, the forklift aisle, so there's a door here that goes to another room. So that's a different space. That's a different space, which is why I said I don't believe they're going to reconfigure their furnace, because you couldn't fit much else in this space. Yeah.
How long does it take to each basket in the furnace? How many baskets?
It's about a 7-hour cycle time going through and out. And it's the chain's sort of slowly moving for that 7 hours. You hang them on, they go through. They could probably have about 4 baskets waiting to go into that process as you hang those up on the chain over here.
Move the basket with the basket? Is that manual or is that?
Yeah. I think the 2 guys pick them up, hang them on the thing. And they definitely fill them on the floor and then lift them up, put them in. Probably about 100 pounds per basket, tops. So it's 2 guys can do that. You wouldn't want to be doing it all day long. But so 7 hours, go through about 5 at a time. I think they're doing about 7 to 8 of these a day is sort of their throughput. Yep.
Are the baskets able to handle more weight, or is it like a basket of 100 pounds?
It's the size of the furnace. That's the basket that fits in the furnace. Any other questions? Yep.
I don't mean it's important, but like for their customers, are they competitive? Can't buy the pack.
So I remember once there's a bearing. So the snowblower. You guys, anybody ever seen a snowblower? Yeah. Okay. So there's a shaft that powers the auger part on the snowblower. It comes off the power thing. There's a bearing that goes through. And so I do remember once that I needed to replace that bearing on my snowblower in the middle of a snowstorm. And I came and rooted around in one of the cabinets in Washburn shops, found the exact same bearing, same part number, and it was manufactured in that facility. So their customers are everybody, including WPI. Actually, somebody gave us that. We got this whole cabinet full of bearings that somebody donated once. Maybe it was them. Yeah.
Are there any, like, at what point in the manufacturing of the bearings, are there any dimensions that are critical that are already made and that they're going to watch out for?
All of the dimensions are critical on the bearings. They're already been made.
So you're thinking like a finished part?
It's like the last step before they assemble them. So, but they're also very hard. You're not likely to damage them too much by handling them. I mean, all the dimensions are critical. They're at finished dimension by the time you receive them. Any other questions?
The layout of like a forklift lane,
Yeah.
that can't be changed at all. Is that a door or all that?
So yeah, the forklift comes through a door here and leaves through a door here, and the loading dock here serves both directions. So you may be able to put a stoplight there, but if you've got something that has to take up that space, you have to be able to move it out of the way for the forklift to come through. So you basically have this space and this space to work with, and so let's put some dimensions on that for you guys. We'll call this 5 feet. And we'll call this dimension here to the wall 12 feet. That's 12 feet, not inches. So you get 12 feet by 5 feet here, and this, what's that? If we put it to scale, then that's probably 15. Any more urgent questions you want to ask before you go back to your office?
So do the baskets contain only the same size bearings, or can they?
Each basket will only have the same size bearing, and you're likely to be dealing with the same size bearing for a whole day. So the mix-up of sizes, you may change sizes once or twice during the day, but yeah. When you're doing 2.5 inch bearings, you're doing 2.5 inch bearings until they're done making that size, and then they switch sizes. So you don't have to worry about identifying what size it is when you pick it up. But yes. First time anybody asked that question when we did this exercise. I guess maybe everybody just assumed they were. Any more questions you need to ask before you go back to your office? All right, everybody, go back to your office. And at 1:15, I would like a rough plan for how you propose to automate the system. So you don't have to have details, but sort of what processes do you think you want to employ to automate the system? Oh, there's an important piece of information I didn't give you guys. The baskets change shape over time. A brand new basket is nice and square corners and flat and all that stuff. After it's been in and out of the heat treat furnace 5 or 6 times, it's a little bit wiggly and wavy. It maintains the basic geometry, but not all baskets are exactly the same size and shape. They're mostly the same size and shape. You could have a 1/2 inch variation in locations of stuff, including the bottom of the basket, which does this. It's sort of wavy after they get used for over time. So not all baskets are exactly alike, but they're all very similar, which adds a complication to the system. But visualize how you will automate the process of putting the bearings in the baskets. And ring out, as you're talking about that, ring out any more questions. But now you're back in your office. So now if you want to ask the question, remember you're going to call the customer. In this case, you just shout out the question. But all right, so 1:15. Not all facilities are laid out with the most efficiency in mind. They just happen.
They can't just switch it around.
You might be able to. Yeah, I think. I think you could. Yeah, you're not going to move the furnace, but I think you could adjust the aisle a little bit.
Yeah.
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 I'd rather have them assembling the battery next to the furnace than across the lane to the furnace. That's my first thing.
Anybody ever been in a heat treating facility
Very, very hot.
in the summer? It's hot.
Well, if we're doing it, if we're like having automation do it.
It is. Well, that's one of the good reasons to have automation do it.
Yeah.
So those guys don't have to stand next to the furnace half the day.
Yeah.
At least they're not quenching in oil.
So, it's not first, very cool mechanism. It's kind of, and don't, and that could don't really. At least that takes care of the bottom. We know that it has the pallet on the bottom, so there is a
Yeah.
So each crate contains only one size bearing. So what you really have to control here is orientation. Right, because there's a top and a bottom, and they have to be stacked with the top up. But each crate only contains one size, so you don't have to. At least when you reach in, you don't have to figure out what you have. You just have to figure out the orientation.
How much variation is there? Which is this very
In the basket, or in the parts.
in the part? I guess where.
They're very precise. If they're all within 1,000.
Meaning where is the variation in the shape?
Oh, is the top? Yeah. So
The outside or is it
it's on the top surface.
top surface?
Top surface has a tray in it for the.
Essentially, what I'm asking is if we were to make some sort of cutout that
Mhm.
had a shape that matched the bearing, are the top and bottom identical? So,
No, the top is physically different from the bottom. It's a different shape on the top than it is on the bottom.
Yeah.
They all have to be the same orientation. They always put them in with the top. Well, I call it the top because of the side that they put up. That's the only reason I named that side the top. So they always put them in the same way, and they need them to be the same. I don't know if they actually need it, but they said they needed it.
really big magnet. That's not super powerful.
And then if some of them are upside down, they can pick it off and turn it around.
Yeah, I was assuming that they all came just like a
I was
magnet that
assuming, like, you
It
get.
would be so nice if they all came in the same orientation.
so we do need to worry about.
No, they're just like thrown in the crate.
Yeah, that's what I was like.
The crate itself is like a pallet on the bottom and wooden sides, and so assume that they're taking them off the lathe. They're actually, I suppose at this point they're taking them off a grinder, but they're taking them off the grinder, throwing them over their shoulder into the crate. That's how they're stacked in the crate. It's not a horrible question. They have an operator at that end. That operator touches each bearing. They need to be the same orientation as each other. That's definitely a need. They always put them the same way, but I think that would be fine. You hang it from the other side, right? You guys have a general idea of how you want to solve the problem? So I don't have to have details, but have you decided sort of how you want to approach solving the problem? All right, so you guys have a general idea what you want to do? Or are you still thinking? Okay, what are your half ideas? Just general, big picture. What are you thinking? Some sort of so something that they could get dumped into. So, all right, so you put the basket on like a slider, and you've got something that's orienting the bearings and then dropping them in as the basket moves underneath. I mean, the other way you could do that is you just need relative motion between the dropping arm and the basket, right? So you could scan your arm back and forth, or you could rest the basket back and forth. And when you get to the right place, drop it in. What keeps them from falling over as you drop it in? Yeah, there's a solution. There's an easy solution, but I just. So yeah, so in the basket, they're like stacked like the basket's on end, and the edge of the bearing goes to the bottom of the basket, not the flat of the bearing. So if your basket is down like this, and you're dropping them in, which I like that sort of method of let's just move to the right place and put one down, because that's what the person does, right? They move to the right place and put one down. If the basket's flat like this, they're going to go and fall over. So if you tilt it on an angle, then they'll stack, right? So yeah, that was my only question. I want to make sure you guys understood you had to put it at some sort of an angle. And if it's all the way like this, gravity won't let them drop. So maybe on a 45, and then you can put them in there like that. So you want to have some sort of a sleeve that they slide down basically that drops them in. Okay. Well, you said you had another idea? Possible idea? So like a magnetic gripper of some kind? I think it would be possible to design a magnetic gripper that would work, even with the orientation thing. What was your sort of big picture idea for how to do it? You guys? Okay. Okay, so same idea. How about you guys? You have a different idea? Did anybody say they wanted to use a 6-axis robot? Okay, go.
We figured like using a mechanical sorting machine just to kind of like drop them out one at a time, and then the robot has an electromagnetic gripper that picks them up and stacks them.
Electromagnetic grippers, and pick them up and stack them. Okay. So you guys want to go with a robot? You guys want to go with a custom automation system that you design and build? Okay. So our homework for this week, and let's we have on the schedule for next week. Where's the schedule? What we got? PC schedule. So we got on the schedule for this is next week, right? Group presentations. So what I would like you guys to do, and should we stay in the groups that we've ad hocly formed here, or should we split into our regular lab groups? What do you guys think? And who's not here? 1, 2, 3, 4, 5, 6, 7, 8, 9. Is there like one person not here? Yeah. And he's in your group? So if you guys 1, 2, 3, 4. So if Connor joins you 4, then that's 5, 3, and you're missing 1, 2. 1, 2, 3, 4, 5. That would be 6. But Alex could join your group, right? Or do we just go back to our regular lab groups? How many lab groups do we have, Ryan? We have 5 lab groups. And how many people in each group? Is it a group of 2? Is the group of 2 here? You're from the group of 2? You guys join one of the other groups and work together with them. And then the other group, and that would make 4 groups, right? And then Ryan will devise a way to combine those 4 groups together. What I'd like you guys to do is prepare a proposal to bring back to the Icy Hot heat treating people for your idea and your estimated cost to build it and install it. Okay? So your idea, and it's a proposal, you don't have to have done the engineering yet, right? Because part of the cost that you're going to bill them for is the engineering to design it. So you're making a cost estimate, so you have to give a presentation that makes them believe your idea is going to work. And a cost estimate so that they can award you the contract. So how many groups do we say we have now? 4 groups. And so 2 groups need to present on Tuesday, and 2 groups need to present on Thursday, because that's how many days we have. So Ryan, figure out a way so that people can sign up for their presentations. But I think everybody should have a written proposal here by Tuesday, so it's just a matter of when you do the. But, I don't know. They could arm wrestle. They could. We can have a mechanism to decide who goes, or people could sign up. Any group right now know they want to go first? Because I always wanted to be the first group to present. Because you know what that meant? You were done with that after your presentation was over. I think everybody with a written proposal on Wednesday, 2 groups present Tuesday, 2 groups present Thursday. Sound good? And you guys are welcome. I had the opportunity to be in Miami right now. And I am here talking to you with -3 degrees outside and going to Miami tomorrow instead. So you guys are welcome. Everybody I'm meeting with is already in Miami.
What's in Miami?
Conference.
You happen to be going to 10X
I am.
after my dad's going to work?
There's still seats available. There's still seats on the airplane available too.